So now moving on to lecture 2, we're going to talk about the 8 phases of civil engineering systems development, which is like the main idea of the course. And in this framework, we really try to understand how every infrastructure system or system in general, whether a bridge, a highway, water treatment plant, progresses from an idea to reality and eventually to the end of its service. So, as introduced in the book by Dr. Samuel Labby, every civil engineering system goes through 8 distinct phases. These phases are not just sequential, they reflect how engineers systematically plan, execute, and manage complex projects with long lifespans and wide societal impact. These phases are needs assessment, planning, design, construction, operation, monitoring, preservation, and termination. Needs assessment is where everything begins. We ask ourselves that question, do we need a new system? What problem are we trying to solve here? Are there demands for increased capacity, safety, or efficiency? For an example, is a new bridge needed due to population growth? Is an existing water system failing to meet the demands? How do we approach this? As engineers, we gather data, analyze current conditions, and finally determine the necessity and scale of the intervention we have to do. Once the need is established, the planning begins. And in the planning phase, us as engineers and planners in general, we evaluate locations, configurations, approaches, aesthetics, functional relationships between the system and its surroundings. Planning is both conceptual and strategic. We look into the concepts very well, and then we develop proper strategies. It considers environmental impacts, land use, and whether the system involves new construction or improvements to an existing facility. Now, design is about bringing the plan that we decided on in the previous phase to life with precision. This phase is both an art and a science. It's a combination of both. So engineers apply mathematics, mechanics, material science, and other regulations to produce detailed specifications, drawings, dimensions, materials, methods, you name it. Multiple design alternatives are studied to bring it to life. And also they are explored, these design alternatives, and ultimately we select the best one. So we have a lot of options, not just in the design phase, but in all the phases. Once we decide on a design, then we have construction. So we decided on our design, now we have to build it. And here as well, we have multiple options to select from. Again, it's all about checking all these multiple options and then deciding which one is the best. And then once we have finished the design, now we construct. And in construction, we have multiple options. And then once we have constructed, we now start operating, right? Which is when the system begins delivering its intended purpose and service. Cars drive on the street we just built, water flows through the pipelines we have constructed, people start inhabiting the building, stuff like that. Phase 6 is monitoring, where engineers keep track of the system's condition, usage, performance. Are there any cracks, anything unusual, environmental impacts happening? For example, we place sensors that may detect stress on bridges or track air quality near highways for environmental impact. And from there, after we do the monitoring, we put those sensors, we kept an eye on our structure. Now we preserve. And in preservation, we focus on maintenance. We asked what needs to be repaired, when should we intervene and repair it? How can we extend the system's lifespan through minor or major rehabilitation, right? And we have many forms of rehabilitation. recycling, general rehab, replacement, or even demolition of some parts and reconstructing it. And once that is done, and you have used this system or the structure for X long of years, the end does not mean specifically demolition. A system might be repurposed, sold, partially decommissioned, So termination or end of life is about you removing a system, an object, an item from your liability. You're not liable for it anymore, right? So it's you recycle it, you donate it. This is also end of life. And across all of these 8 phases, the tasks are as follows. First, we need to describe the system, really understand what's going on, what's in, what's out inside the system, and then analyze its conditions and alternatives and evaluate the options and outcomes of the system. So, what is possible? And finally, based on that, or before finally, really, optimize performance and cost. So, lay it all together and try to make them integrate to figure out the optimal path forward, and then select the best option. Select the best course of action or the best option. And these are the main tasks of, the civil engineering practice. You always have to do this. It's always the case. It's always you have multiple options and you need to figure out the best path and the best way forward. And to do so, we always keep in mind measures of effectiveness or MOEs, or sometimes we call them KPIs, which are quantifiable metrics that tell us if our system is performing well. This includes stuff like travel time, cost per unit, safety incidents, environmental impact. Along with that, we identify stakeholders, which are system owners, users, affected communities, and definitely always the general public. A stakeholder is someone that can affect or be affected by a certain project. And each stakeholder brings different goals, risks, and expectations. And this has been a quick summary of what the 8 phases are. It's generally a full system for anything in life, not only civil engineering systems, from the beginning until the end. It's a full cycle. So, best of luck. Make sure you read your chapters and review the material. And let's jump to the next one.